Hi everyone, welcome back to Chem Help ASAP. In the 1930s, Linus Pauling, who was the winner of not only the Nobel Prize in Chemistry but also in Peace, developed the most widely accepted method for measuring electronegativity. Now, Pauling was exploring the nature of how atoms share electrons, and specifically he was looking at how atoms don't always share electrons equally. Since then, chemists have used his electronegativity method to quantify the different kinds of bonds that atoms make. Electronegativity is represented by the Greek letter chi, and it's a way to quantify how much an atom will attract electrons to itself when it is in a chemical bond. Now, electronegativity is used much more often by chemists than electron affinity. Electronegativity will decrease moving down the periodic table. It increases moving from left to right. The reason why electronegativity decreases moving down a group or down the periodic table is because as you add more core electrons, they increase the shielding, so those valence electrons don't feel the pull of the nucleus as strongly. The increase in electronegativity as we move across the periodic table from left to right is because the electrons feel the attraction of the nucleus more strongly because you are not adding more shielding, but you are adding more protons. Chemists often measure the difference in electronegativity for two atoms that are bonded so that they can measure the degree of ionic character of a bond or how polar a covalent bond is. Here are the ranges for delta chi. If delta chi is less than or equal to 0.4, you have a nonpolar covalent bond. If delta chi is in between 0.4 and 2.0, you have a polar covalent bond. Now, once you're beyond 2.0, you have an ionic bond. I have a table here with some electronegativity values, and let's just quickly calculate the delta chi for a couple bonds. So let's look at a chlorine-bromine bond. Chlorine has an electronegativity value of 3.0 and bromine's value is 2.8. So our delta chi is simply 0.2. This falls in the range of nonpolar covalent bond. If we look at the carbon-oxygen bond, oxygen has a value of 3.5, while carbon is at 2.5. That gives me a delta chi of 1.0. That clearly falls in the range of a polar covalent bond. If we look at table salt, sodium bonded to chlorine, chlorine has a value of 3.0. Sodium has a value of 0.9. Our delta chi is 2.1, which is definitely an ionic bond. Linus Pauling did an excellent job of giving chemists a way to quantify the different kinds of bonds. And this helps us with other properties such as nucleophile strength or intermolecular properties. I hope you found this video helpful, and thanks so much for watching.